Hi, my name is Yusuf from Western Michigan University. I want to give an update regarding our project, what we are doing for the Myosa, make your own sensor application. We want to appreciate them for giving us the opportunity to participate in the competition. We are very grateful for that. So the update based on that, we've received the kit and we've started working on that. So, our project is using the accelerometer and then the gyroscope to monitor the heart rate. So instead of using the electrodes, which needs, so what we are using to monitor the heart rate is the accelerometer and the gyroscope, and we are doing that in real time. So as we can see, so we have the Myosa project, the Myosa sensor, which is the MPU 6050, which is attached to this. So we have it close to this, and that's been reported in the literature that we can monitor the heart rate, which was 95%. So we want to also implement that and then want to improve the algorithm. So this is a home-run heart rate monitor, which is what we are benchmarking our results with, and then we also have the Vital belt, which is we are comparing whatever we are recording, or what heart rate we are recording. We are benchmarking it with standard equipment, which is the Vital belt from AD Instruments, and then we have other base too, and then we have a wristwatch, a smart wristwatch for monitoring the heart rate. So currently now we are at the data acquisition stage, and that has been going on very well. So we developed this our custom interface, and then we can see this is connected to the ESP32, and then we are recording the data at 100 hertz, and then showing on the interface. So we have the data from the sensor, which we can see the acceleration, the angular velocity on this interface. So we are currently using that, and then we are recording this at 100 hertz. So we developed this custom GUI interface to get that data. So from this data, we'll be saving this data, and then we're processing that. We're planning to use an independent component analysis, and also use machine learning techniques to in order to get the heart rate of the subject. So so this is the data recording we can see. So later on we use ICA to split the data to get the heart rate, and we've done some processing already, which has been very successful. So let me stop this, and then I'll go to this, and I'm gonna run some algorithm. Let's see. So this is the processing we've done, and if I run this, so these are the data we've collected. We are recording the data, we are saving it as a CSV file. So these are part of what is implemented. So these are the detected. We use fast ICA. So this is what we are doing. We have detected some peaks. We see some peaks, which is from. So we are currently considering when the subject is just sitting down, then we can see the peaks of the heart rate, and then we're able to calculate that. And, okay, so we're able to calculate that, and then we're able to get the heart rate to be around 84.15 beats per minute. And then when we also measure that with when we compare that with all the standard equipment, it was around this range. But later on we want to have more subjects, so that we want our system to be data proven. So that is the next thing. So we are currently at data acquisition. We want to have at least maybe probably 10 participants or 10 subjects to participate in this experiment. So we collect that data, and then we're going to use machine learning techniques. So currently now we are just using independent component analysis, fast IC, to segregate the signals, and then we're able to see the peaks. So we are planning to improve this, and then we'll look at how the results, and then we'll compare that with the standard equipment. So that is that, and then we also have a 3D printed casing, which is what we have done for the for our packaging. So we have this. So what we plan to have is we record the acceleration and also the angular velocity from the accelerometer and also the gyroscope. Then we send that, we do all the classification on the microcontroller, and then we send the result to the ESP32 here. So this will display the heart rate of the subject after the competition. And also we have a mobile app which I will also be sending the video of that. We've developed an application that it's also send that heart rate to the mobile application too, and it also displays the heart rate, which provides both the haptic and also the visual feedback. So currently now we are data acquisition, and we believe that we're able to achieve that before the conference, and I believe we are on track. So currently now we are just gathering data, and we are processing the data so that we can develop our own model, and then we can see how it goes. And then we use different performance metrics, and then we benchmark it against the standard equipment to make sure that we're able to achieve. So that is our work progress, and we are working as fast as we can regarding this project. So, and everything has been going very well, and we believe that we'll be able to complete the project before the conference. So thank you very much. That is the update regarding projects. And I'm very, very grateful to Myosa for their support and for the opportunity given to us. And I believe we'll do a very good job and make sure we have this. And we want our work to be research-driven, not just only executing a project. We want something that can be published later in a good journal out there. So that is what we are working towards. So thank you very much, and we really appreciate it. Thank you.